Any idea what this means?
Way that equations are run.
Kind of like what they said, like a system would be like probably more than one, like the way it's going.
Perfect.
More than one in a problem.
Exactly. Awesome. So a system is when there are two or more equations in one problem.
Oh, yeah.
So that's why it's called a system. So we're going to group it as a whole thing, and we're going to see how it runs together, in a sense. Okay. So you'll get more in depth in this next year when you take algebra, but this is kind of an introduction section, but it carries on with our graphing that we did. So when we talk about the systems of equations, there's three ways to solve a system, okay? And when we say the three ways, this is how you're going to go about trying to get your answer, okay? So the number one, or the first way that we're going to talk about is by graphing.
When do we get done graphing?
Never. Not anymore.
So
Graphing will be in every math class that you take from here on.
No, I have a question. Like, will we be more like lessons that have to do with graphing?
Just specifically graphing?
Yeah, like, yeah.
Today and tomorrow.
Okay. Yes.
When you get into Mrs. Harpenaugh's class, in like Algebra 2 especially, then you'll start using graphing calculators.
Whoa.
So you can graph it right on the calculator.
What do those look like?
I'm not going to show you so you don't go get one and cheat for this.
Okay.
Okay? So, the first thing we're going to do is by graphing. Maybe I want to do this in a different way. No, that's all right. So, what do we need in order to graph?
2 points, usually 2 points.
Okay.
One.
Okay, maybe I said it wrong. What ways could we graph it? Okay, so remember, by graphing, you could do the intercepts method. And again, I don't care how you graph it. Everybody remember the intercepts method? This is where you put 0 in for one of the variables, 0 in for x, and you find a y. You put 0 in for y, and you find an x. And then you graph those 2 points. So you can still do that. And it could be a positive or negative. I could use a table. Remember the table ones? That's where we make something up. If I have my x's and my y's, -2, 0, and 2, and make up those numbers, and I find the other one. Okay? And what was the most recent thing that we used? And what did we call that method? Yeah. Slope intercept method. And as you said, it is y equals mx plus b. And again, it really should say plus or minus m plus or minus b. But our main goal here is to get the y all by itself, to solve for that y. And then what would we, what's important about the b? What does that tell us?
You only graph it first.
Okay, so this is my first point, and it's on the y-intercept, right? Or this is called my y-intercept, so that tells me what? I can only go up or down. Up, positive, down, negative. Okay, and then we're going to use our m, which is my slope. And that's when we now think about the rise over the run. The top number tells me to go up or down. The bottom number tells me to go right or left. Okay? So, any of the three methods you're going to be able to use. I don't care. You just do it. Alright? However you feel most comfortable. I still think this is probably the easiest and fastest way. most of you want to go and do it as fast as you can, so you get done, and then you can do other things. But totally up to you how you get it, okay? Don't forget about our special lines. What are my two special lines?
Vertical and horizontal.
Vertical and horizontal, perfect. If I have horizontal lines, what variable do I use?
Y.
Y
Y, awesome.
and X.
So y equals plus or minus some number, right? Positive or negative. And vertical lines are x equals plus or minus some number. Okay? So you're gonna have multiple equations in one problem, and you're gonna have to graph both or three or whatever it happens to be. We're gonna start out real simple, and we're only gonna have two equations. When you get into algebra and algebra 2, and you do this, you could have like 3 or 4 different equations, and where those equations or lines cross on your coordinate plane, then it will make like a figure or something. So it'll turn it into a quadrilateral, or you can make like a stop sign or something. It's kind of cool, actually. All right. So this is how I'm going to solve it, by graphing. Okay, by graphing. My other way that I'm going to solve is number 2, by substitution. Have you ever done problems by substitution? Realistically, probably yes, you have. But what does that mean to you, in general?
Change it out for something else. Yeah, change it out.
Yeah, okay. So we're going to put one equation into a second equation. And why would we want to do this?
To find more answers.
Okay. But why would we specifically want to do this?
So we can learn more math.
Because if you think about my equations, like when we have y equals mx plus b, how many different variables do we have? 2, right? The y and the x are variables. The other things are numbers that we can put in there, right? So we have 2 variables. So when we do this, we put one equation into the second equation. You're trying to have only one variable in the problem. And that's why we do this.
Wait, don't equations have equal signs, right?
Equations have equal signs,
Okay.
yes.
Yeah.
So these are the 2 methods, and we'll get more specific here and show you examples of this, but I just want you to show the 2 ways that we can do it. And then honestly, the third way, you could do this by elimination. You don't even have to write this down if you don't want to, because we're not going to do this method today. But elimination would be the third way that I could do this. And in all honesty, again, this is probably the one that I would use the most often. But we introduced this section because of the graphing portion of it. Okay?
Isn't that what you always try to do in math?
Eliminate?
Yeah.
Well, again, we're trying to eliminate one of my variables to get only the equations to only have one variable. And that's why we call it elimination. But again, that'll be next year for you guys. Okay? But when Ms. Sarpinall asks you what are the 3 ways to solve a system, you could raise your hand and you'll know what those are. By graphing, by substitution, or by elimination. Make sense?
I'd be the person to say,
Okay, fine.
use a wrench.
Next part is the answers in a system. So there's 3 ways to solve it, and there's three ways to get an answer. Okay? So the first way that I can get an answer is probably the most common, and it is a point. So I'm going to find a point, and obviously a point means that it's going to be an XY value. It's an actual ordered pair. Okay? So when I'm graphing, this point is going to be found by where the two lines cross. So you're going to graph both of them, you're going to see where they actually hit each other, and that answer is solving the system. Okay, so you can have a point, or another way of seeing this is there's one solution. And that one solution is that specific point where they cross. Okay? Now, when you do substitution, your one point is just what you come up with when you eliminate one of your variables and you actually see the coordinates of your point. All right? Number 2A. Again, now this is how I can answer the question. I could have an infinite number of answers. So let's think about this. If I have an infinite number of answers, what's that mean?
There's no way that you can find an
There's no
answer.
definite answer.
There's no definite answer. There's a ton of answers, right? A lot of them. Okay? So think about this. If I graphed one line, and then I had an equation, a second equation, how would I know that every single point on that line is a part of my answer? What would have to be true about the two equations or the two lines that they gave me?
They have to be higher or lower.
They could like cross.
What do you mean higher or lower?
Like, higher than the original number or lower than the original number?
Could be like cross.
Okay, maybe. Well, but that's how we found the answer to this one. So there's got to be a different way of differentiating between the two answers. If this is where my two lines cross, so if I had two equations that they gave me,
Where they line
and
up?
they crossed, right? Wherever they crossed, that's the first one solution, and that's my solution right
Be
there.
on top of each other,
They'd be on top of each other, or they're what?
side to side.
Not parallel. They're what? What does it mean if they're on top of each other? They're actually what?
Stacked.
So they're what?
A wall?
If this is my first line, and then my second line's right there, how do I know that they're the same thing?
They line up.
They're exactly the same thing, right? So essentially, an infinite number of answers means the two lines are the same. Now here's the tricky part of this one right here. Sometimes they might not actually lie on top of each other, so you might not see that they're the exact same line. One of them could be over here, and one of them could be over here, and there could be a gap in between them. But how could I know that they're possibly the same line?
Line up.
So what would they have? What would this line right here and this line right here have in common,
They'd be
even though there's a
intersected.
gap? They're going to have the same slope. So make sure you write that down. Two lines are the same because they have the same slope. Now this isn't the definite reason why, but it kind of clues you into it. Okay? So what do you think the last way of answering the question is? If we could have 1 point, we could have an infinite number of points, or we could have what?
No.
So what would we say there?
Empty set.
Empty set or no solution. Exactly right. What's my symbol for no solution?
Zero and one.
Perfect. 0 with the slash through. What's my, coming back to this one, what's a symbol for infinity?
Sideways.
Eight sideways.
My sideways 8, right?
Switched out a little bit.
Okay. So, you could use the symbol to name all these. Now, let's go back to our lines though. So the first one, to get 1 point or one solution, my lines had to cross somewhere. The second one, basically they're the same line, either right on top of each other, or if we extended them, they would run into each other, right? Because that's why it's a line, because they got little arrows on the end. Now, how do I get no solution?
Parallel lines.
Parallel lines. Perfect. So no solutions means the two lines never touch. So we have parallel lines. Now, here's a question. What's true about their slopes?
That it could be, they both be different.
They don't have a Y? Oh. I thought I was thinking.
They have no X.
If they're never going to touch, my slopes also have to what?
Never be on the same line.
They're gonna be different?
They're gonna say different.
They can't be slanted.
I just did it.
No, like one can't be slanted and then the other can't.
Well, yeah, I agree with that. If they're like this one's gonna eventually hit it.
That's not parallel.
Yeah.
That's not parallel. So if things are parallel, they have to have what about their slopes?
Different numbers.
They're exactly the same. So this is where it gets a little confusing. Parallel lines are parallel because they have the same slope. Think about vertical lines. I make it simple. I make it very simple. If this is a vertical line and this is a vertical line, will they ever touch?
No.
Because they have the same slope.
But didn't the other one have the same slope also?
This one has the same slope, yes.
Like the second answer?
Oh.
Yes, you're right. So this is the confusion. Just because you see that the two equations have the same slope, you know you have a special case, but you still got to look at graphing it because they both have the same slope.
Okay, now I get it because if they had the same slope, they would touch because they're going the same amount of times, but they have the same different X and.
They started.
Exactly right. So I'm going to go, for instance, I'm going to go up 2 over 3, up 2 over 3 on both of them.
They both started at a different Y.
They just start at a different point. Exactly right. Perfect. Okay, so does that make sense to everybody? So I could have special cases if they have the same slope, but I still got to kind of look at it if it's the exact same line or if they're parallel lines. Okay, make sense? Now, how do I get these two answers though if I'm doing the math? And the math is the substitution way. So how do I get the same answer? Well, I can solve the whole thing and I'll get a point at the end. For an infinite number of answers, if I'm going to do substitution and I get an infinite number of answers, at the end my variables are going to cancel out. When I do the math, trying to bring everything to one side or the opposite side, my variables are going to cancel out. And at the end, I'm going to have some number equal to itself. If I have that, that automatically tells me that I have an infinite number of solutions. If I have no solution, when I do the math equation, I'm going to do the exact same thing. I'm going to cancel my variables out. But at the end, what shows a no solution is when I have a number that's equal to something else. 4 can never equal 5, right? If I do math. Cannot. No, shake your
Yeah,
head.
I know. I was
Okay.
agreeing to what you said.
So when you do the math and my variables cancel each other out, I'm left with something at the end. If they're the same, it's an infinite number of solutions. If they're different, it's no solution.
Okay.
Okay?
Well, it'd be a complex equation, but I found out a way to do it. So.
No. You can't
Yes.
do it. Trust me, you can't do it.
You take
Trust me, you can't do it. So here we go. Let's try it out.
5 and 2.5. Multiply.
Does anybody have questions with the words? All right, so the first one we're going to do is, let's do y equals 2x plus 1 and y equals negative x plus 1. So a lot of the times when they do systems of equations, they might put them and write them like this. Put them inside those little brackets and show it to you as an actual group.
So
Okay?
the X and the Y have to be the same.
So the first thing that I want to make sure of is that they're in y equals mx plus b. Are both of these equations in that form? Yes. So then the next thing that I'm going to do is I'm going to go over and I'm going to graph both of them. Okay? So if I look at that top equation right there, how do I graph the top equation?
Start at 1.
Start at 1 because it's my y-intercept, right? So I go up 1, put a dot. Now, how do I use my slope?
Up 2 to the right 1.
1, 2, right 1. How many times? 1, 2. Got to have at least those, right? Okay? Then I get my ruler. Don't forget to use a ruler. And I connect my dots. Now, realistically here, if I would have done the other part before I connected my dots, I would have not had to really connect my dots because as soon as I start the next problem, what do?
It's a solution, it's one.
It's my solution, right? Because if I go up 1, I'm going to put a dot right there, right? Because that's how I'm going to graph this equation too, correct? And then how do I graph this slope?
Go down 1 and left to the right 1.
To the right, right?
It's
And then I'm going to go down 2 and over 2. But if you notice it right away, honestly, you don't even have to finish your graph. Okay? So here's the question. This is my answer right here, right?
Yes.
But what is my answer?
A point.
And what's the answer?
1.
What's the answer?
X flat.
No,
What?
it's a.
Okay, it's one solution. You're right about that, but what's my answer?
Where they cross.
So what's my answer?
1, 1, 0.
1.
Comma 0.
Is that right?
Is that zero?
No.
No, 0, 1.
0. 0, 1.
Now is that right?
Yeah.
Okay? So again, this is huge for these. It is one solution because they actually cross. But you have to write that one solution as a point. If you don't write it as a point, you get it off. Okay? So you still have to do it on your graph. You still have to figure it out, but then you have to write it as that one solution.
If there's a negative 1, it always be 1, number 1. If there's 1 positive, 1 negative, it would be always 1.
Yes. Yes.
Or you just have to find.
But don't just go by that.
Yeah.
I mean, that's a for sure thing, but they could both be positive and both be negative and still cross. Trust me, I'll show you that. Okay? Questions here?
Well, your white intercepts always be the same.
No.
So yeah, they won't cross into the Y, so then you have to put
Right.
multiple numbers.
So let's try another one. These are all graded questions, but we're going to prove all of your answers here in just a second. Let's do this one. Y equals x minus 1. Y equals 2x minus 2. So I don't have the same y-intercepts. I don't have different kinds of slopes, meaning positive or negative. So we got to now come back and do the actual problem. Okay, so first equation, is this in y equals mx plus b? Yes. So let's do this equation right here. How do I graph it?
Down 1.
Down 1, then what?
Up 1 to the right 1.
Up 1 to the right 1, up 1 to the right 1. Or, remember, I can always do what? Any number over itself. So I could do 2 over 2, and this is the same thing, right? And then I'm going to go up 2 over 2. Everybody agree with that?
Yep.
Okay? So then, quickly, I would just connect my dots. And again, I might not actually make it into a line by putting my arrows because I'm more concerned about the dots this time. Okay, now how do I graph the second one?
Down 2.
Down 2.
Up 2 to the right
1, 2 to the right 1. As soon as I hit that, I really don't have to do anything else. Right? Because that right there, when I hit this spot right here, that's my what?
Crossing point.
That's my answer, right? See what I'm saying there? So when I draw it, this is my answer. Everybody see what I'm saying there?
Yeah.
But remember, I have to answer the question. So yeah, it's one solution like Carson said in the first one, but what's my answer?
1.
Wait.
Now we have 1, 0.
Mr. K, if there's a negative in any part of the equation, is it crossing?
Not necessarily.
So like, the ones with the numbers, not the y, but anything before the y.
Over here?
Not to the right. Like, so if like that's negative, and then the other one's negative.
Are you talking about
I don't know.
the slope?
You're saying the slope?
No, any part of the, like, it crosses, like, there's a negative in the problem.
Not necessarily.
Like, it can't be a negative one, but, like, anything that equals y, so like,
Here, watch. Those are gonna cross automatically because they have negatives?
I believe so.
What's the rest of you think? Obviously, I'm trying to prove
Wait,
it
no,
wrong, right?
no, no.
I don't really
No, they're
understand.
gonna be infinite.
I don't really understand what he's asking.
It's gonna be infinite? You're still wrong.
No, because the 5 and then 7 are different.
So what do we have here?
No solution.
No solution because these two lines should be what to each other? Parallel.
Because the fraction of the same distance.
So how do I know they're either parallel or the same line?
Oops.
The y-intercept is different.
How do I know that they're either parallel or
Same.
the same
Slope
line?
is the same.
The slope is the same. Because I have the same slope, I know I have a special situation. Okay? Understand what I'm saying?
Let's see.
So how do I graph this?
Go down 5,
Down 5, then what?
down 1 to the right.
Down 1 to the right 3. Up 1 to the right, left 3. Okay? So there's one of my points, or one of my lines, sorry. And then how do I graph the other one?
Go up 7,
Go up 7.
down 1, and to the right.
See what I'm saying now?
Oh, yeah.
So when, okay.
See, the problem with you guys, and I'm glad you're thinking, but sometimes you and Connect want to make up stuff just so you, make up stuff and you think you find an easier version of it. But sometimes you just got to realize, hey, I got to do the math sometimes. And sometimes, even though that I sound smart when I say, oh, I found a new way, it's really not a new way, and you're making more work for everybody. Okay? So like I said, I'm glad that you guys are actually thinking about this. But sometimes you just got to admit that you have to do the work. Know what I'm saying?
But every, so
Just go through and do the work.
they cross every time the fraction isn't the same, and then there's a negative.
Oh yeah, that's convenient to think about. That's convenient to remember.
It's like,
Next.
How is
Okay
that?
with the graphs?
How's that
it's
convenient?
All right, here's the next one. So here's my substitution method. So again, if they give you this, remember now, I can decide what way that I'm going to do the problem. So remember, my ways of doing the problem are either graphing it or by substitution. I can do either method every single time. But again, how many of you are going to carry around graph paper all the time?
Wouldn't it be two
Probably not,
C's?
right? Okay, so I can do this whenever I want with substitution. The problem with substitution is when you get into more and more complicated equations, substitution will work, but you might work with fractions in your equations, and some of you don't like that. So then that's where elimination would come into play. But again, it's totally up to you how you want to solve the problem, unless it specifically tells you how to solve the problem. In our quiz, in our test, it'll specifically tell you, you have to solve this system by graphing or by substitution. Okay? But when you get into geometry, you have all three versions at your disposal, and you can use any of the three all the time. And again, that's where probably I'm going to tend to this one. But I'm going to use substitution when it's obvious. And how do I know when to use substitution?
When it equals.
I would use substitution when one of my equations is just one variable. Then it's going to be really, really easy to use it.
So if we use like the graphing method, well, we have to turn in our graph table paper
Yes.
with that.
Why?
Alex?
Why do you feel like you would use elimination?
I'm going to use elimination a lot. Unless I look at this right here. Doing elimination is going to be more work than what I can do. I can do this problem very quickly.
But what is elimination? Are you not-
Don't worry about elimination. Okay? You don't have to know about that this year.
Why does it put the 6 there and y equals 6 instead of just putting 6 for the y?
Because it has to be two different equations.
But it's
This is
you're
an
initially-
equation and this is an equation.
You're initially gonna put it there more than likely, so why don't they just put it there?
You have to put
Anyway. So, here's the process. If I'm going to do substitution, so we're going to solve this by substitution. I'm going to always find one of the equations that it's solved for one of the variables. So does everybody see that it's solved for y in the second variable? Y is 6. So I'm going to substitute that 6 into the other equation for the y. So again, basically, I'm trying to get one of my equations to only have one equation, and then I'm going to stick it into the other. So I'm going to substitute, but as I rewrite it, I'm going to put the 6 in for the y. So I get x plus 6 is equal to 8.
It's kind of like combining it because.
Yeah, kind of. So what's x? Yeah, because I subtract 6 and I subtract 6. So see how substitution is really easy?
Yeah.
But again, what's my answer? My answer is either one of these three things. Is it 1 point, no solution, or an infinite number of solutions?
There's no point in putting it there.
What? What is my answer? Yeah, x,
6.
x equals 2 was how we solved, but what's my answer?
Y equals 6
What?
equals 2 plus
Shh.
8.
One solution, and what's that solution?
2, 6.
My solution is 2, 6. So in this problem right here, you always have one of the answers given to you. Put it in there and use it. Y is 6. That has to be a part of my answer. Okay? If I would have graphed these two things, we would have done the exact same thing. This would have given us a slanted line. This would have been what kind of line?
Oh,
A horizontal line, right? And they would have crossed at 2, 6. If I would have graphed it. You see what we're doing here?
yeah.
I mean, look kind of lost and confused today. Even more than normal.
I'm just confused why they just don't give you the answer.
So, okay here? Alright, next one. So my system is 2x plus 3y equals 6. And my other equation in my system is x equals 3. So, substitute and find out what is y.
0.
You're wrong again.
How? Wait. Maybe.
Everybody get an answer? So again, I'm going to substitute it in to there, right there. What does 2x really mean?
2 times
2 times 3, right? 2 times 3 plus 3y equals 6. 2 times 3 is 6 plus 3y equals 6. How do I get y alone? I cover that up, right?
Yeah.
So I do what to 6?
Subtract.
Subtract 6. Whoops. So what's y? Y was 0.
Then your answer.
But my answer is,
2,
where are you getting 2?
6.
It's 3.
We have 3.
X is 3.
I was right.
I know.
Why were you trying to confuse me?
Because I don't like to say you were right.
Okay.
Yeah, because you said it was 0.
Questions here? You always have one of the answers. Alright? Now, look at this one. Negative 2y plus 4x. I do not think you have one of these, but I want to show you guys this so you're not totally confused next year. And then x equals 3y. So look at the difference between this one. This one has something with the other variable.
Wait, you have to find y.
Okay? So, I'm going to put parentheses around this 3y. And when I substitute this time, x equals 3y. I'm going to put 3y in for that x, but I have to put 3y. And it's got to stay inside my parentheses. So I have negative 2y, that comes straight down, plus 4 times x, but now x is 3y equals 12. See how we eliminated one of my variables and I just have y's in it? So what's negative 2y? What's 4 times 3y? What's negative 2y plus 12y?
It's 1.
How do I get y all by itself?
Where'd you get the 12?
3.
Where did it- oh, sorry, it's 10. My fault. So what's y?
1.
Now, how do I find out what x is?
Just take 3 times 1.
I gotta put it, so in some of these problems, you might have to substitute 2 times. So what's x? What's 3 times 1?
3.
So what's my answer?
3.
Don't forget to write it as a point. If you don't write it as a point, you get it wrong. Okay? So, these are the ones that you'll get more into next year in algebra.
Okay.
Okay? And then the elimination would come about by having 2 sets of these kind of equations. But again, you don't have to worry about that for this year. Okay? So, questions with the words and the examples of those? So here's the problems. Make sure you follow the directions. If they tell you to graph, then graph. If they don't tell you to graph, then just say solve the equations. You get to decide how you're going to solve it. Then you can do graphing or substitution. Okay? And like I said, next year in algebra, then you'll learn elimination and you'll have 3 different ways to actually solve the problem.